Okay, guys, so here we are. We are going to solve some differential equations. If you recall, we talked about what a differential equation was. It was an equation that had a derivative, and the goal was to get back to the original function. So if we have a y prime here, our goal is to get back to y. So these problems are going to get more interesting. I think we had super easy ones when we first started doing integration, but for something like this, it's going to get a little cuter. So the first thing we should do is change y prime to dy over dx, and that's equal to negative 4xy squared. So now once we've done that, the next thing we need to do is separate to integrate. It's an oxymoron, I get it, but that's what it is. So that means I want my dx over here, and I want anything with y's on the other side. So all my y's over here, all my x stuff over here. So if I do that, the first thing I'm going to do is I'm going to multiply both sides by dx. So I have dy is equal to negative 4x squared, x y squared dx. Now the problem is this y squared is in our way, so he's got to go. So how are we going to get him to go away? Well, we're going to divide both sides by him, so we're going to get a y squared down below over here. So this turns out to be 1 over y squared dy is equal to negative 4x dx. So now if you take a look, I started up here, right? Actually, I started here, and my goal was to separate to integrate. So now that I have separated, I'm ready to now integrate, okay? All my things are in terms of y over here, all my things are in terms of x over here. If you look over here, 1 over y squared, be careful, it is not the natural log. We change this to y to negative 2, and if I take the antiderivative of y to the negative 2, I get negative 1 over y is equal to, and then the antiderivative of negative 4x is negative 4x squared over 2, which is negative 2x squared plus c. You must remember that it's a plus c there because every derivative has infinitely many antiderivatives. So now if I want to solve for y, because we're not done, I want it y equals, not the negative 1 over y equals. So what I'm going to do here is I'm going to multiply everything through by negative 1. So by doing that, I get this, and then if I multiply this, I get 2x squared. Now, if I multiply negative 1 times a constant, I still have a constant. So technically, that doesn't change. Now, if you go back to your Algebra 1 rules, if I want to solve for y, if I flip this is technically over 1, so I want to flip that. So I can say that y is equal to 1 over the entire quantity of 2x squared plus c. This whole thing is in the denominator. So they call this, if you recall, the general solution to that differential equation. And remember, if we want to find the particular solution, I'll give you a set of ordered pairs to plug in to find c. Okay? I'm going to pause and go get a new one. Okay, this next one over here, and our goal is, again, to solve this differential equation. And if you look over here, get the particular solution with the initial condition of f of negative 1 is equal to 1. So again, the first thing you want to do, the first thing you say to yourself, anytime you want to solve a differential equation, your goal is to separate to integrate, okay? Now, be careful because you want your dy and your dx to be quote-unquote upstairs, okay? Because that's what you're taking the antiderivative with respect to. So again, the first thing I'm going to do over here, okay, actually if you want to, you can cross-multiply both sides if you do that, so that way you don't screw up. So that way you don't screw up, and then you could just kind of take it from there, and then just... Okay, so I'm sorry, Mr. Havron just bothered me. Anyway, all right, so we have cross-multiply, I get this, and then dx times the quantity, because you guys have an issue with parentheses. I don't know why you like to leave them at the bus stop. But anyway, so here we go. So dx and dy are in their respective places, but the variables don't match, so we have to basically divide this by both sides and divide both sides by 1 plus y. And if you do that, it should bring us to 1 over y plus 1 dy is equal to 1 over x dx. Now, if you look at this, I sincerely hope you're like, I have separated, now I am prepared to integrate, okay? This one here, if you do U-Substitution, we would let u equal y plus 1, and the derivative of y plus 1 would be 1, blah, 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 blah. So this would wind up being a 1 over u. And if it's a 1 over u, that should be telling you guys that because it's a 1 over u, it's going to be a natural log. And then this guy is clearly also another natural log. So if I find this, this is going to be the natural log of the absolute value of y plus 1. is equal to the natural log of the absolute value of x plus c. Now what's interesting is, again, my goal is to solve for y here, guys. So I want to show you something interesting and cool, and it's really important that you pay attention to this. If I want to solve for y, I have the natural log equals this and the natural log of this whole quantity over here. So now what you want to do is you want to go over here and say to yourself, what am I going to do here to undo the natural log? And I sincerely hope you guys are all saying to undo the natural log, you do his inverse, which is, you got it, it's e. So we're going to raise e to both sides, and when I say e to the both sides, it's this entire thing over here. So if I do, up top, e to the natural log of y plus 1 is simply y plus 1. And then e to the natural log of x plus c does not become e to the natural log of x plus e to the c. If you go back to your little rules for exponents, if I have 2 squared times 2 to the third, that's equal to 2 to the 3 plus 5. So if I have the sum of two things and I want to go backwards, I can rewrite it as a product. So this is going to be equal to e to the natural log of x times e to the c. Now e to the natural log of anything is anything, because we know e to the natural log of e to the natural log of y plus 1 is simply y plus 1. So we get y plus 1 equals over here, and then e to the natural log of x is simply x. And then over here, if I do e to a constant, it's going to equal a constant. So we always like to say let e to the c equal c. So this is going to be equal to c times x. So technically, if I solve for y, it's going to be cx plus 1. And what's interesting is your general solution actually looks like a linear function. So now our goal is to plug this guy right in over here. So now if I do that, okay, actually it should be the absolute value of that, I think. Well, that's never going to be negative. So I have y1 is equal to c times negative 1 plus 1. If I subtract 1 from both sides, I get 0. So I get that c is equal to, did I do something wrong? Hold the, oh, this is minus 1. Shar. This is a minus 1. I hope you guys caught that. Minus 1. So that means I'm adding 1, so I get 2 equals negative c, so that means c is equal to negative 2. So that means my general solution was this guy right here. Actually, this guy here was my general solution. And now my particular solution, I'm just going to plug negative 2 in. So I get y is equal to negative 2x minus 1. So y equals negative 2x minus 1 is my particular solution. Again, I'm going to hit pause and pull up another one. I'll be right back. Okay, so we have 3 different differential equations that we want to actually solve here. I'm going to change this to pink because pink is a pretty color. This one is a cute one because if you look at it, all of this is in terms of x. So again, if I want to solve a differential equation, the goal is to separate to integrate. So with that said, this is a cutie patootie because I just have everything in terms of x. So all I have to do is multiply both sides by dx and integrate both sides. So this is going to give me dy is equal to x times cosine of x squared dx. So if I come over here, I get this. Now if I look at the left-hand side, the antiderivative of dy is just y. So this actually is y equals. Now, over here, this is a little more interesting, and I hope you guys recognize that you're going to have to use U-Substitution. So if you look at this, you're going to say to yourself, I'm going to let u equal. Here's what I think you should do. Hit pause now and solve this out yourselves by using U-Substitution and see if you come up with the same answer that I do. I'll see you soon. Okay, for those of you who are like, I'm not doing that, let's move on, and I'm going to let u equal x squared. So du dx is equal to 2x. So that means that dx is equal to du over 2x, which is nice because it's going to make that guy cancel out over here, right? So that means I have the integral of x times the cosine of u times du over 2x. My x's say sayonara, and there's a 1/2 I'm pulling out. So I have y is equal to 1/2 times the integral of the cosine of u du. And the antiderivative of the cosine is the sine. So that means this tells me then that y is equal to 1/2 sine of x squared, and most importantly, plus c. So this represents the general solution to this differential equation. So that's your first one. Let's take a look at your second one. In your second one, I have y prime is equal to this exciting thing over here. And ask yourself, what's the first thing I'm going to do? And I sincerely hope you said, let's change y prime to, you got it, to dy dx. So we're going to change it to dy dx, and I'm going to use a different color so that way it doesn't look like everything's merging. So we have dy over dx is equal to x squared plus 2, I'm butchering that with my handwriting here, over 3y squared, right? Okay, so now we want to separate to integrate. So for me, as I'm looking at this, I'm going back to algebra 1. I'm like, I need all the y's on the left side. I need all the x's stuff on the right side. So if I cross multiply, I have a feeling that's going to do my separation for me, which is pretty fabulous, okay? So if I look over here, this times this just gives me 3y squared dy equals x squared plus 2 dx. Now the dy and the dx definitely need to be at the end, because this is saying you're taking the antiderivative of this side with respect to y, and then over here it's saying you're taking the antiderivative with respect to x. That's why we want them on those ends, okay? So now we know we're ready to integrate. So the antiderivative of 3y squared is just y cubed. And then the antiderivative, this is cubed, this is x cubed over 3 plus 2x plus c. Now, if I want to solve for y, because we're not done, how do I get rid of y cubed? I hope you all said you take the, yes you do, the answer is the cube root. So you're taking the cube root of x cubed over 3 plus 2x plus c. Everything is inside that cube root. And that right there, again, is the general solution to this differential equation. I'm going to ask you guys to do C on your own, and we're going to go over that on Friday. So if I ask you to do that, I'm telling you right now, make sure it's on a separate sheet of paper so that way I can collect it if I would like to. And I'll be right back. Okay, so this is the last one I'm going to show you, and then, like I said, don't forget that other problem, that C on the previous thing, I want you guys to do on a separate sheet of paper in case I want to collect it. But here we are. Here is the final one I'm going to show you. And if you look at this, this is pretty cute, because if you look at this, it's y prime, right? We want to solve the differential equation. I should say solve the dE. Solve the dE. So again, first thing we want to do is change y prime to dy dx. Okay, equals x minus 1 over y. And the cool thing again is we want to separate to integrate. So now if you look at this, I got a y downstairs, so I can multiply both sides by y and multiply both sides by dx. And if I do that, I get x squared y dy equals x minus 1 dx. Now if you're looking at this, you better say to yourself, I'm not done yet, because there's an x squared hanging out with the y's over here. He's not allowed in this party. Like, he's not, like, get out. You know, you have to leave. So you got to go to this party. So you should all recognize that you're going to divide both sides by an x squared. So if I do that, I wind up with y is dy is equal to x minus 1 over x squared dy. So now that we have successfully separated, now we're ready to integrate. And when you look at this guy, this should be an easy one. This is like a y squared over 2. But this one here, we're going to have to kind of do a little something special to it before we do anything. And the answer is no, we're not doing U-substitution. No, we're not doing long division. We're just literally dividing each term out. So I have this, I get y dy, because I'm just going to tidy this guy up here first. If I take this and divide it by this, I get a 1 over x. And if I take this over this, I get over x squared dy, dx. Oh, I said dy. Well, look at all these dy's. Ooh, sichua. So that should be a dx. I'm sorry. Oops. Oopsies. Ooh, that's an x. Ah! Butcher. Sichua almost butchered it, but that was a quick recovery. Okay. So this one over here, this becomes y squared over 2. This right over here, I hope you will recognize, is the natural log of the absolute value of x. And then this dude right here, the antiderivative of negative 1 over x squared, again, you change it to negative x to the negative 2. If you take the antiderivative of that, because this is negative, it actually winds up being 1 over x plus c. Now, again, we're on the hunt for solving for y, so the first thing we're going to do is multiply everybody by 2. So I get y squared is equal to 2 ln absolute value of x plus 2 over x, and then 2 times a constant is still a constant. Now, to undo the y squared, we take the, you got it, square root, but be careful, it is plus or minus. This whole thing sits inside the radical, okay? Plus 2 over x plus c. And I hope you guys look at this and say to yourselves, there's no way x can equal 0 because of this and because of this, where x cannot equal 0. This plus or minus represents the general solution to the differential equation. And what's interesting is when I ask you guys to find the particular solution, sometimes the y-coordinate will be negative, so that means you're using the negative one, and then if it's positive, use the positive one. Good luck, and I'll see you tomorrow. And yes, there is definitely homework. It will be in the textbook, along with that other problem I asked you guys to do.